cool. Thanks. Thanks, Dimitri. Yeah, I hope to do a demo here to kind of put everything that these folks have said and bring all this to life. Yeah, my name is Aimore. I'm a machine learning engineer working in this app called ARBI. So first of all, I'm here in my terminal. I'm just gonna bring NV top, which will monitor the GPU in the machine.
It's running right there on that machine right there.
Yeah, the small one. So we'll see that once I start the code with Docker Compose up, sorry. You see that there will be like 4 services being created. And one of them is the app itself. The other one is the LLM service. The other one is the embedder. And the 4th one is the vector database. We can see there on the right-hand side that there's like a peak of memory being used. So the models, the embedder and the large language model are being loaded into the memory of the GPU. And now if I go to the app, refresh this, you can all see the app right there. I understand that some of the, like the letters here will be small, but I'll, speak loud what it's saying. So first of all, we have like a welcoming message, a place where you can drag and drop files. At the bottom here, we have like a user input for text and questions. On the left-hand side on the panel here, the side panel, we have a place where the user can put their access key, which also works the same way as, like a username and the password. It's just like, it's kind of like easier to have just one token created. Some instructions on how to use a conversation history, like a threads, and also like an uploaded files table. You will see this being populated soon. Now, why don't we start with, like a simple example, asking, who are you? And once we ask that, the assistant answers, I am an AI language named ARBI Assistant, created by ARBI.CITY to provide helpful information on international arbitration. I'm designed to be intelligent, detailed, and well-structured in my response, but I'm also humble and only provide information that I'm absolutely sure of. As you can see, it provides an answer to our question, and it shows its purpose as well. Why don't we, complicate a bit more? Like, let's ask, like, who is Dimitri? And it said the assistant answers, I'm sorry, but the passage provided does not mention anyone named. Please let me know the passage or context in which the name appears, and I'll do my best to provide more information. So it's good because, we don't want our model like hallucinating or making, being overconfident and saying things that are not sure about. But we can also fix that by providing some context with documents. So what I'm gonna do right now is to upload a document, and it's actually like Dimitri's CV. And when I hit this button here, everything that Marilyn and Dimitri said about the document being parsed, chunked, vectorized, and the vectors stored in the database will happen. So this is all gonna happen like in the behind the scenes. And you see it's quite quick, and it also generates like this key for us here, which I as a user, I'm the only person who has this key. And I'm the only person who will be able to kind of unlock my documents and conversations as well. Like in the future, we'll planning to do that. But as you can see, the document was uploaded here, the name of the document, and it has like 5 pages. Just one fact that in that machine, if we are embedding, like doing this process of uploading a document, the whole Shakespeare pieces, it contains 3,000 pages. It runs less than a minute. So it's pretty fast. Like imagine like all that Shakespeare produced, 1 minute, it's there, like at your, access at your fingertips. So now let's ask the same question who is Dimitri, but as the same question, but now the model will have access to the CV or like the document that we have uploaded. And the answer is Dimitri is an individual with multiple nationalities, including American, Russian, and British. He's highly recommended arbitrator and arbitration counsel with over 2 decades of experience in investment treaty and commercial disputes. I guess it doesn't contain like the tech side of things, right? Like, yeah, the CV. But it looks like the Dimitri I know. And we can see here like why the model now answers this. There are like the passages that the model use to, to base its answer. So because you can see here, like there is like first passage happens also like in page 5, the second passage happens in page 1, and they are not like sorted by page, they're actually sorted by relevance. How useful is this piece here to actually answer the question. And we also have like a feature that converts answer into PDF. Let's take a look into that. So this, it generates like a PDF with some headings, like a disclaimer, but 4 main contents about everything that you care about, like the question and the answer that you were provided. It has like the query, the answer, the passages, and also like the documents, or in this case here, like Dimitri's CV. So you can see that there is a, like the highlights, and if we click, for example, like passage 5, it will take you directly to where that, it's being sourced, like that reference of that passage. Now, so how is this like kind of like possible? So I want to show now that, some of this tech stack that we used to build this app were based in Infinity, which is like an embedding inference server. It's a high throughput, like low latency REST API for serving vector embeddings. We also use like TextGen, which is, or also called like as UBA. Here's like a tool or framework that allows you to load and serve large language models. And it has a nice UI as well. And finally, the vector database. So here we have the collections. So the collections, you can imagine, is each collection is like a user that uploads X many documents there. And as you can see, they're all encrypted. That like looks like gibberish here, but it's because they are encrypted. So this will be like the name of the collection. Also like the page content that everything has been like encrypted, as well as like the metadata. So for example, document name, the document key, and so on. I also would like to show here that in this specific collection, there are like 534 vectors. It depends, of course, like how many chunks, like the parameters that you set in the chunking process, and the size of your document. And there's also like a nice visualization here that if we run this, it will plot this, hyperdimension vector into two dimensions, and you'll be able to kind of, hover around and see each point of this is like a vector which represents a passage, right? So if there were not encryption here, you'll be able, for example, if you're doing like some experimentation, you'll be able to see how good is your embedder. And you can maybe drive insights if you'd like to about these documents that being embedded. I know this was like a quick demo, but yeah, I would like to thank everyone who came here today.